Hey guys, we're looking at our 3.2 homework geometric definitions in Khan Academy. All right, so I'm going to get my draw tool at the ready. So we've got a figure down here, and let's see what's going on. They're telling us line, right? We know it's a line because there's arrows in both directions. So line AB and line CD intersect at point O as shown below, okay? Select the most precise and correct statement about perpendicular lines from among those that are given. I don't think we've had time yet at this point to talk about it, but perpendicular lines, they form like an X shape where they intersect, but in order for them to be perpendicular, they form a right angle. So it's forming a right angle. So perpendicular lines form right angles. That's 90-degree angles, okay? So let's see what our options are, all right? Line AB is perpendicular to CD if the two lines intersect such that the measure of angle AOD equals the measure of angle BOC. Yep, so all of them will be equal to 90. So far that one looks good. But let's just make sure. Let's check. I guess I need to get rid of that. Let's keep checking. Option B, AB is perpendicular to line CD. If the two lines never meet, oh no, those would be parallel lines, right? When they never cross over, they never intersect. But that's different than perpendicular. They do intersect. They form a right angle. So not option B. Let's check option C. So line AB is perpendicular to CD if the two lines intersect such that angle AOD is a right angle. Ooh, yeah, they have to be 90 degrees. Okay, so far this one is looking good. This is really good because we're talking about a right angle. Let's go back to A and see what was different about that. So they're perpendicular if the intersect so that the measure of AOD equals BOC. Okay. But I don't think, now I'm thinking it's not A because this could be AB, and then this could be CD, right? And then those two angles would still be congruent because they're vertical angles, but right, we can draw them in different ways. They're vertical angles, they are congruent, but it doesn't necessarily mean that they're perpendicular, right? This is clearly an acute angle. This one's obtuse up here. So they would be equal, but they're not specifying that it's 90 degrees. So now I'm having doubts. Now I'm like, maybe not A. So let's go ahead and check. Yay, perfect. Did they explain? Okay, let's see what their explanation was. So interest ABD, blah, blah, blah. Yep, it needs to form a right angle. Yep, just like what we said. Oh, I think this is showing why it's not. Yeah, perfect. Yep, this is like just like what I said for the vertical angles, right? They could be vertical, but it doesn't mean that they're right. Yeah, not necessarily perpendicular. Awesome. All right. Next one, let's check. So we're just kind of refreshing geometric definitions. Can you match the teacher's comments to the definitions? Okay, got this. Let's see. So definition of an angle, these different students' definitions, and then the teacher's comments based on this figure, okay? So we've got this figure here. I feel like I'm going to need to annotate too again. So let me just get that at the ready. Okay, Deru's definition of whatever's going on here. So an angle is two rays. So for example, VA and VB that share a common vertex, which would be point V. That is true. An angle is formed by two rays. This is excellent. So I guess we just drag it. Correct. Okay. So that one was correct. Let's see Oliver's definition. So it seems like we're defining an angle, maybe. An angle is the amount of space between two rays. For example, angle A. Okay, I need to choose a different color here. Angle AVB, okay, so same angle, is the amount of turn between VA and VB. What were you thinking of the measure of an angle? Were you thinking of the measure? Oh, yeah. So I guess that is talking about the measure. I guess that matches. Okay. So the amount of space, right? That sounds like it's going to be talking about a specific distance, right? A specific degree. Oh, and this, oh my gosh, I just noticed here. The goal is to find the definition of an angle. Okay. So my bad. I should have caught that first. So Oliver's saying it's the amount of space. So this seems to match. Yep, he is talking about a measurement, right? This amount, this degree. Is it obtuse, acute, right? How much are we turning? That does sound like a measure, not just a general definition of an angle. So far, this is looking matching up correct. And then just to make sure, let's check Carlos's definition. It's an angle is the intersection of two lines such as AC and BD. So when two lines intersect, that's what an angle is. I don't think, I mean, it's forming angles, but we would need to be more specific in if our goal is to define what an angle is. So Duru's definition is awesome. Yep, it's two rays that intersect to form an angle. All right, let's check. Yay! All right. I think on your end, it's different questions. So you can be using this video to help. Let's go to the next one. Let's see. So same concept. This case, we're trying to define a line segment, and we've got our teacher's comments. So Duru's definition of a line segment. So let's just give like an example too of a line segment, just to recap what a line segment looks like. So if this is like EH, that's like an example of a line segment. So it's a line connecting two endpoints. Yep, it's a line segment is a line connecting two endpoints. Yep, that looks good. A line segment in which 3 points are all on the same line. That doesn't necessarily mean it's a line segment. So maybe not quite. A line segment is part of a line, not the whole thing. Okay. Yeah, a line segment could be part of a line, but not the entire thing. So it seems like a line segment connecting two endpoints. I feel like that's the most specific. So we're just kind of like, we're just gauging here. So, true array would also, okay, let me see. Line segment with 3 points are all on the same line. That sounds like collinear if they're all on the same line. Line segment is part of a line, not the whole thing. Okay, I need to figure out which one was talking about array would fit the definition because I just noticed that as our option. A line segment is a line connecting two endpoints. Okay, maybe it's that one. That sounds right. Line segment, 3 points are all on the same line. That's collinear. Part of a line, but not the whole thing. Maybe that could be array too. Let's check. Okay, let's see how they answered. Oh, nice. They've got visuals too. So Oliver's definition is incorrect. 3 points on the same line is collinear. They're all on the same line. Collinear. That has nothing to do with the definition of a line segment. Oh no, poor Oliver. Carlos' definition is interesting because at first glance it might seem correct. To prove that it's incorrect, consider array AB is part of this line but isn't a line segment. So Carlos, a line segment is part of a line but not the whole thing. So yeah, it could be, I guess also example would be array. And Duru needs to be careful with the language because a line extends indefinitely in both directions. A line connecting two endpoints. So you can improve the definition by clarifying that a line segment is only the part of the line between two endpoints. Yeah. And that was like the visual that we had. It's just the endpoints. Okay, so these ones are kind of tricky for the teacher's comments questions, but try your best. Let's see here. Parallel lines. Hopefully we're feeling at least confident with parallel lines because we've done this before in Unit 1. Select the most precise and correct statement about parallel lines from among those that are given. Lines L and M are distinct lines that line the same plane. Okay. Line L is parallel to line M if a third line P can be constructed such that it intersects lines L and M both at right angles. That would be true. We haven't covered this yet in class, but if there is another line that's like a bisecting line and they're forming right angles, why is that true? This is kind of like a backwards proof of our angle measures because ways to describe this angle here, and this angle here, those are corresponding angles is what they're telling us from that line A or option A. They're basically telling us if we have like transversal corresponding angles are congruent, then the lines have to be congruent. And that's true. Remember, we were looking at the different ways to name angles, angle pair relationships. We always started with two lines that were parallel. So this is just working backwards. So before we were saying, okay, these two lines are parallel, this transversal comes in, so the corresponding angles must be congruent. So now we're working backwards. They're saying, hey, we've got corresponding angles. Now the lines must be parallel. So this is, I'm gonna guess it's gonna be A. This is just like a backwards proof where we're, instead of starting with given the lines parallel, we're finding the corresponding angles, we're given corresponding, and now we're finding out that they're parallel. Okay, that was sounds a little bit confusing. Let's just make sure. Option B, line L and M parallel if they can be drawn so that they don't touch each other. Okay, that sounds good. But this one's more specific. Option AC is more specific. Line L and M are parallel if and only if they are close together, but they don't have to be close together, right? They could be parallel lines, like one's up there, one's down here. They're still parallel. So that one doesn't seem, because it's saying close together, that doesn't seem specific enough. Let's check option A. All right, and we'll check. Oh, good. They've got examples too. So if and only if they are close together but don't intersect, not quite right. Yep, closeness, it could be drawn different ways. If they're drawn such that they don't touch, oh, so these ones could be drawn that they don't touch, but eventually, because they're lines indefinitely going on definitely, eventually they could touch. Ooh, that was a really good visual. And then perfect, this one. So if we've got right angles being formed, then it means they are going to be parallel. Okay, I've gone through a lot of your homework, so go ahead and use this video, kind of reference reviewing geometric definitions. If you need more help with this too, if you're like, I'm not really remembering this, I recommend jumping up here to these two videos. They're very helpful in just kind of like refreshing, like what are those geometric definitions and the terms? How do we label stuff in geometry? So these two up here. So again, how I got there is I just clicked this little arrow. All right. Beyond that, if you guys have any questions, please let me know. Have a great day, guys. Bye.